Okay, now let us talk about the concept of collinear vectors and points. So I actually describe this in two particular cases. I'll talk about collinear points, right, and I'll talk about collinear vectors separately, right. This is what I intend to do. So if I talk about two vectors, so see, if we talk about 2 points, right, 2 points are always collinear. Nothing needs to be proved here. They are always collinear. Okay. So, but if we want to talk about two vectors, yes, that is when the question start. Two vectors, so vectors is basically ray, right? Remember, so we can talk about rays being collinear or not. So if you want to talk about two vectors being collinear, so the funda is that A should be equal to lambda times B. If this is the case, then A and B are collinear, right? This is the rule. A and B are collinear if A is equal to lambda times B, where lambda is a scalar quantity, right? If you can express the one vector in terms of the other vector where only the magnitude is changing. The other important observation of this fact is that, let's say if I say A and B are two non-coplanar, right? Non-collinear. We'll talk about coplanar also. They are non-collinear points, and it is given that xa plus yb is equal to 0, right? If this something like this is given, we know that if you see, this becomes what? That means something like this. And in fact, if you see, they are arranged something in the terms of, so here lambda role is being placed by minus y by x. This used to happen when they were collinear, but here it is given that they are non-collinear. So the rule says that if this is happening, then x must be equal to y equal to 0. Very important stuff. So if the vectors are non-collinear and they are written as a linear combination, then the coefficients should be all 0. This is how you should remember this. Okay, now let's talk about the points. So 2 points are always collinear, we know this fact. Now if we talk about 3 points, now yes, then the question arises, because by 3 points you can form 2 lines, and when there are 2 lines, then only we can try and talk about vectors. So let's say there are A, B and C points which are given to you, right? So they are two and they are basically capital A point, capital B point and capital C point. So method one here is to form lines out of it. So for example, you can form AB vector and AC vector. You can draw like this, and if AB vector is equal to lambda times AC vector, right, this implies then points are collinear, right? This is what you can do immediately. Points are collinear. The other method that you can also apply here, that without doing this particular activity here, is that if you can express A, B, C as xa plus yb plus zc is equal to 0, where x plus y plus z is equal to 0, then also I can immediately say that A, B and C are collinear vectors or collinear points, right? So this is the law that you people have to remember. So for lines, what you will have to remember, A is equal to lambda b. For points, x linear combination when the sum of the coefficient is equal to 0. If they are non-collinear, right, if they are non-collinear, then the coefficients must be all equal to 0. This is the important step. Okay, let's take a question to understand the concept of collinear vectors. It's a ABC are vectors such that they are non-zero and no two of which are collinear. So that means A cannot be written as lambda b, B cannot be written as mu c, and A cannot be written as gamma c. So they are not related like this. If the vectors A plus 2b is collinear with C, so now this is given that A plus 2b vector is collinear with C. So that means you can say it is lambda times C, right? And it is given that B plus 3C vector is collinear with A vector, right? So that means this is mu times A vector. This is also given. You are asked to find the value of A plus 2B plus 6C. You need to find this particular value. Okay, now let's see how this question has to be attempted. It's a very good question to understand the concept of vectors. So if you see here A plus 2B, here there is also A plus 2B. What is missing is the 6C component. So let's add 6C on both sides. Right, if the vectors are equal, so then the addition will not make any change. So this actually becomes lambda plus 6 times C vector. Okay, now let's talk about this one. Here it is B plus 2c 3c, and here it is 2b plus 6c. So can I say, first of all, multiply this by 2, this becomes 2 mu a, right? And here a is missing, so let's add a also on both these sides. So this also becomes this particular stuff, which is 2 mu plus 1 times a vector, right? Now notice that both of them have actually become a plus 2b plus 6c. So that means the value of both the RHSs, these are the two RHS, should also be equal, right? And if we make them equal, this comes out to be lambda plus 6 times c vector is equal to 2 mu plus 1 times a vector. Can you see that this is nothing but a scalar quantity? Let me call it lambda dash c, and this is another scalar quantity. Let me call this mu dash a vector. So actually what you people have done is you have represented this something like this, which is nothing but definition of collinear vectors. So that by means you have actually proved that a and c are collinear vectors. Okay, but whereas it was given to you in the question that no two of which are collinear, remember here, no two of which are collinear. So if there are two non-collinear vectors, so we just did the formula, if two non-collinear vectors are there, that is, let's say xa plus yc for example, and they are given in a linear combination, then if they are non-collinear, it is given that they are non-collinear and they are given a linear combination, then only thing that can happen is that their coefficients must be 0. So for example here, that means lambda plus 6 should be equal to 2 mu plus 1 should be equal to 0. This is the only possibility that we have. Now if we just put the values of lambda plus 6 here, then what the answer is? Yes, absolutely. So the answer then will become 0 here. Answer here will also become 0. So the answer that we were trying to find is 0. This is the particular answer to this problem. Right, just go through the question once again. It's a beautiful concept to understand how collinear and non-collinear in the same question work. Okay.